Hello and welcome to Technical Utkranti. And today we are into the fourth question for data structures and algorithms. So today the question would be on finding the subarray with the largest sum. Let's quickly revise what we have done in the series so far. So setting matrix zeros, the question was identify all the elements with a particular characteristic and then make all the elements of the row and the column in which that element is lying to zeros. Uh, the second question was making Pascal's triangle. Uh, Given n as a number, you have to make n rows of the Pascal's triangle. The third question was next permutation of elements. For example, if it is 123, then we had to, the next sequence or next permutation would be 132. So that was the question, and it was a really interesting one. Now, today we have to find the subarray whose element sum is maximum. So, how would it look like? So, you're given an input array like this. You have to find the subarray within this array, the sum of whose elements is maximum. So in this case, it comes out to be this particular array and its sum is 6. And you won't be able to find any subarray whose element sum is greater than 6. Okay, so how are we going to go about this question? Before reaching conclusion uh, for the solution to this question, we need to give each element a chance, right? Okay. So in order to give each element a chance, what we can do? So let's start with the first element because the subarray will have at least one element. And let's say we start from the left side, we have -2. Now, in order to consider 1 after having considered -2, what we can do? We have two choices. Either we include 1 in the existing array that we have analyzed, or we can start a new array from this. So both these choices, the sum, in case of both these choices, I have written here. So if I include 1 in -2, the sum would be -1. And if we start a new array from this element, the sum would be 1, that element itself. So both these choices I have written over here. Now at each level, so for example, we are at this level, we'll maintain two things. One is maximum sum for the given choices. Why are we maintaining this sum over here? Because this will tell that at the current level, whatever choices you have, the maximum sum that you can get from these two choices is this. So that when you go on to the next element after this element, what is the choice that you should consider moving ahead, right? So for example, at this level, I have sum of -1 and 1 both. So of course, I'll go with this particular choice, not this particular choice, right? The other way would have been to just exhaust all the choices and then find the maximum sum, but that would have been a brute force solution. What we are instead doing is at this level itself, I'm identifying what is the best choice, and then I will move ahead with the best choice itself. The second sum I am keeping is maximum sum till this level. So this is best of the two choices, and this would be maximum sum till this element inclusion. What this indicates is till previous level what was the maximum sum, and then including the current choice, whatever it is, what is the maximum sum? So that would be the maximum of these two elements. Okay. So for example, when I had minus 2, my level max was minus 2 only because I had no other choice. Array will have at least one element, and the maximum sum also remained at minus 2. Now, when I included 1, I had minus 1. If I sum it with some new element with minus 2, I have minus 1. Or if I start a new array from here, it will be 1. The best of these two choices is to start a new array. Okay. And then till the previous element, the best sum was minus 2. And if I see, like if I compare it with the current level max, I see that, okay, the maximum sum has also changed. Now, when I include minus 3, I will include it from the best option till previous level, which makes which gives me two choices, minus 2 comma minus 3. Minus 3 means that I am starting a new array from the next element, and minus 2 means I have included minus 3 with the previous best level, which was 1. Okay, so in these two choices, it says that including the current element with the previous best is better, and the maximum sum till here still remains at 1. All right, now I go on to include 4, and this gives me with 2 comma 4. Level max, like the best of these two, is 4, and my maximum sum is now upgraded to 4. So till now the maximum sum I've got is 4, right? Now I have next element as minus 1. So now again two choices I have is 3 and minus 1. The level max, like best of these two choices, is 3, but still the previous sum like holds. All right. Now when I include 2, I have 5 comma 2. Best of these two is 5, and now my sum is upgraded to 5. Okay. Now just look at this particular thing. So when I was including 4, the sum changed to maximum sum changed to 4. When minus 1 was there, like including 4 to minus 1 resulted in best sum of like 3, right? But still, like if I would have just included 4, it would have been better, right? But we don't know that, okay, even if this element is negative, later on it might get even bigger number, like in this case, which is 2, and including 4 minus 1 2 would be better than just 4, right? So that's what we see here with this algorithm. We see that, okay, the like after including minus 1, my sum became 3, but then I included 2, and I got like at the current level I got 5, and my maximum sum got upgraded to 5. I hope it makes sense, right? So similarly, I go on to include or consider each and every element. At each level, I find the best choice to move ahead considering the next element, and at each stage I update the maximum sum, right? So the maximum sum is the maximum of the previous level max and the current best choice. So I find that my maximum sum goes to 6, which is basically 4 minus 1 2 1. All right, let's look at the code and see what is being done. So the first element I have taken as maximum sum and previous level max. Okay, then starting from the second element, what I do is I calculate the two choices. Two choices is previous level max plus the current element, and the second choice is the current element, like starting the new array from the current element. Then Previous level max comes out to be the best of these two choices that we have calculated, and the maximum sum comes out to be the maximum sum till the previous level and the best of the two choices. So this goes on till the very last element. Uh, like once we have considered all the elements, the maximum sum represents the contiguous array's maximum sum. So we did not get to know the array, the sub array, but we do get to know the maximum sum of it. All right. So let's try and experiment a little bit with this algorithm. So let's say I have 3 comma minus 2. So in this case, I should just get 3, right? Yeah. Now let's say I have 3 minus 2 and 1. So if I include all these three, I'll get a sum of 2. But if I just have this first element, the sum would be 3. So the answer should be 3 only. Now if I make it to 3, let's say, in this case, the negativity which has come up with minus 2 will be overshadowed with the positive 3. So the sum should come up to be 4. Yes. So I hope you've got what I'm trying to say. And yeah, so the lesson learned in this question was that in certain questions it might be a lot easier to find the end result, which in this question was the sum of the subarray. Then the intermediate that comes to mind, like we think that okay, we are given an array, but first we have to find the subarray, and then we'll sum the elements of those subarray to find the sum. But what we saw here is that we directly calculated the sum. Though in the algorithm could be modified to find the subarray, but easily we found the sum without keeping the track of which all elements are included in the array, right? So that was it. I hope you might have learned a lot. Thank you, and please drop in your suggestions in the comment box to make it more productive. Thank you. Bye bye. Hit like, comment, and subscribe.